Isn't it just wild how good math is at describing the universe? Seriously, think about it. It's like the secret code for everything, from the perfect curve of a tennis ball flying through the air to the double helix of our own DNA. That incredible power is what led mathematicians to ask a really, really big question.
Right, let's get into it. If our logical systems are so powerful, are there any limits? Could we, theoretically, build a perfect system of math that could answer literally any question? A system that could prove every single truth there is? That was the ultimate dream. But, it also opened up a pretty scary idea. What if there are truths out there that our logic can just never ever reach? To really get what happened, we need to jump back in time to the early 20th century. This was an amazing time for mathematicians. There was this incredible feeling of optimism in the air. They really believed they were on the verge of creating a perfect, airtight system of logic, like a machine that could solve any problem you fed into it. But while everyone was feeling so confident, there was a problem brewing just beneath the surface. Little cracks were starting to show up in the very foundations of math, and they threatened to bring the whole building crashing down. So to see why, we need to look at what those foundations are actually made of. Okay, so the entire massive structure of mathematics is built on these things called axioms. Axioms are basically the ground rules. They're the starting assumptions we all agree on without needing proof, just because they seem so obviously true. Like if A equals B and B equals C, then A has to equal C. We don't prove it, it's just a given.
The easiest way to think about it is like building a house. The axioms, they're the solid concrete foundation you pour first. Everything else, all the cool stuff we prove, like the Pythagorean theorem, those are the walls, the floors, the roof that we build right on top of that foundation. And as long as that foundation is solid, we can build as high as we want. But what happens if you find a crack in the concrete itself?
And that crack? Well, it came in the form of a paradox. The most famous one was found by the philosopher Bertrand Russell, and you can understand it with this simple little riddle. Imagine a village with a barber who has one very specific rule. He shaves all the men in the village who do not shave themselves. That's it. So the question is simple. Who shaves the barber? Let's really walk through this, okay? Option 1. The barber shaves himself. Well, he can't. His rule says he only shaves men who don't shave themselves. So he just broke his own rule. Okay, so he must not shave himself. But wait. If he's a man in the village who doesn't shave himself, then according to the rule, he has to be shaved by the barber, who is him. You see, we're stuck. It's an impossible, inescapable logical loop. And this wasn't just a fun brain teaser. Russell had found this exact kind of self-contradiction lurking deep in the foundations of math.
So you can imagine the panic. If the very axioms of math could lead to contradictions, then every proof, every single theorem ever written might be worthless. But just when things look darkest, a hero steps onto the scene. David Hilbert, maybe the most influential mathematician alive at the time. And he had a bold plan to save everything.
Hilbert's grand plan was to rebuild math on a totally new, perfect set of axioms. And this new foundation had to do two things. First, it had to be consistent. That just means no contradictions. You can't be able to prove that 2 plus 2 equals 4 and then also prove that it equals 5. Simple enough. Second, it had to be complete. And this is the big one. It means that for any mathematical statement you can possibly think of, the system has to be able to tell you for sure if it's true or if it's false. No maybe, no we don't know, no unanswered questions, ever. And Hilbert was absolutely convinced this was possible. In a famous speech he gave in 1930, he laid down the gauntlet with this triumphant, unforgettable line. It basically became the battle cry for his whole project. For Hilbert, there were simply no unknowable secrets, no problems human reason couldn't solve. But here is where the story takes an absolutely stunning turn. The day before Hilbert gave that incredibly optimistic speech, a quiet 24-year-old Austrian logician named Kurt Gödel had already secretly proven him wrong. He was about to completely dismantle Hilbert's dream, and he did it with an idea that was as simple as it was world-changing.
Okay, here's the core idea you need to grasp. It's the critical difference between something being true and something being provable. Let's take something like the Goldbach conjecture. It says every even number bigger than 2 is the sum of two prime numbers. We've checked it with computers for trillions and trillions of numbers. It always holds up. It feels true. But is it provable? Has anyone been able to logically derive it from the axioms? Nope, not in 300 years. So it makes you wonder,
What if some things are just true, but we can never actually prove them? Gödel's secret weapon was a paradox that had been around forever, since ancient Greece. It was mostly seen as just a little philosophical word game. You know the one. This sentence is false. If you say it's true, then it has to be false. But if you say it's false, well, then it has to be true. It's another one of those self-referential loops. But Gödel saw something no one else did. This wasn't just a game, it was a key.
What Gödel did next was just an act of pure genius. He figured out how to take the logic of that simple liar's paradox and translate it piece by piece into the cold, hard, formal language of mathematics. He turned a word puzzle into a mathematical equation. So he constructed this incredibly complex mathematical statement. But what it said, when you translated it back into English, was devastatingly simple. It said, this statement is not provable. Suddenly, it wasn't a philosophical quirk anymore. It was a concrete mathematical formula that was talking about its own provability.
And this is the checkmate. This is the inescapable trap. Let's just think through the two options here. First, let's say Gödel's statement is false, okay? If it's false, then its claim to be not provable is a lie, which means it is provable. But hold on. If your system can prove something that's false, your system is broken. It's inconsistent. That's a total failure. So, the only other option is that the statement has to be true. But if it's true, then what it says is correct. It is not provable. And now you have a statement that is true, but your system can never prove it. Your system is incomplete.
You see, it's one or the other. Either your mathematical system is inconsistent or it is incomplete. There's no way out. Hilbert's grand dream of a perfect, all-knowing system was impossible. When the legendary mathematician John von Neumann heard Gödel present this proof, he got it immediately. His reaction was reportedly just 2 words: it's over. The shockwaves from this were huge. It completely changed how we think about the limits of logic and truth. But it's also one of the most misunderstood ideas in all of science, so let's be really clear about what it actually means and what it doesn't.
First off, Gödel's theorems do not mean that math is broken or wrong. The bridges we build using math aren't suddenly going to fall down. It doesn't mean that truth is a myth or that everything is relative. And it definitely doesn't mean that the problem on your math homework doesn't have an answer. This is about the absolute limits of the entire system, not our day-to-day work within it.
You know, maybe the best analogy is to think of math as a map. It's an unbelievably detailed and incredibly useful map of the landscape of what is true. But what Gödel proved is that the map can never be the same size as the territory. There will always be true places out there in the landscape that are fundamentally unmappable. They exist beyond the reach of any road our logical system can ever build. And this leaves us with a truly profound, mind-bending idea. Gödel showed that the universe of what is true is fundamentally bigger than the universe of what is provable. There are more true things in the universe than we can ever formally prove with logic. It reveals a limit, not on what we can know or discover as humans, but on what any formal system can ever certify on its own. The world of truth is simply and beautifully vaster than the world of proof, and that gap, as we now know, can never be closed.